Hello everyone, in this video I am going to demonstrate SMPS based power supply design. The input of this circuit is 90 to 220 volts DC and the output is 5 to 24 volts DC. There is no current protection used and I am going to charge a 6 volts battery as a load. You can see here this is how the setup looks like. You can see the battery voltage is 3.8 volts DC now. Here you can see this is how the setup looks like. You can see here this is the control circuit, this is the control section. Here comes the ICTL494 generating a frequency of 65 kilohertz. Here you can see there are two MOSFETs. These two MOSFETs are firing this pulse transformer and the output of this pulse transformer with the help of these two current limiting resistances. You can see here and here 10 ohms. With the help of these two current limiting resistances, the output of this pulse transformer is fed to the IGBT. You can see here this is the first IGBT and this is the second IGBT and here comes the heatsink for the IGBTs. The output of this IGBT is fed to this transformer and the center tap of this transformer is connected to the 90 to 220 volts DC power supply with the help of this choke. This choke is used as an harmonic filter and this will filter out all the high frequencies coming to the circuit. You can see here this is the main power transformer. Output of this power transformer is fed to this, you can see this rectifier. This is a Schottky rectifier and from here pure DC is fed to this filter capacitor. You can see here there are two filter capacitors and this is the load, and from here you can see two wires are coming and they are connected to this battery. So this is how the setup looks like. Here you can see for the input section I am using a bridge rectifier and two filter capacitors. You can see here, and the input section works with a voltage of 90 volts DC to 220 volts DC. So this is how the setup looks like. So now I am going to describe the circuit diagram. Then I am going to show the performance of this circuit. So here you can see this is the control element TL494 IC. So this IC is responsible for controlling this SMPS. So here you can see the output of this TL494 is fed to this pulse transformer. You can see this is the pulse transformer and here you can see there are two MOSFETs IRF840. I am using 200 ohms current limiting resistances, you can see, and there is a pull down resistance of 10K here and here also. So these resistances are responsible for discharging the MOSFET gates. You can see the secondary of the pulse transformer is fed to the two IGBTs. Similarly, here there is 4.7K pull down resistance. Here also there is 4.7K pull down resistance and there is a current limiting resistance of 10 ohm. You can see on both the ends. And this is the main transformer. Output of this main transformer is fed to this rectifier and there is a filter capacitor network. You can see two capacitors are connected in series. And from here you can see one tapping is used with a voltage divider network. This tapping is fed to the pin number 1 of ICTL494. Also between the pin number 2 and 3, I am using 1 mega ohm and 10K resistance like this. So this part has a gain of 100. 1 mega ohm divided by 10K comes 100. So from here you can see this is the reference voltage. You can see 5 volts output is obtained from pin number 14 and pin number 13 and there is a voltage divider. And from here you can see this output is connected to pin number 2 like this. So this is how the ICTL494 controls the voltage. So here you can see the output of the bridge rectifier. I am sorry, this is not a bridge rectifier, the Schottky rectifier. You can see there are two Schottky rectifiers and the output is fed to this load. It is a 6 volt battery load in this circuit. So now I am going to demonstrate the circuit. So let us see now. So now you can see here the control supply is already on. So I am going to switch on the power line. I'm sorry, I have switched it off by mistake. So now I am starting the circuit. You can see here. Now I am going to gradually increase the variac. You can see here the input voltage is, 0.174 volts DC. So now I am going to increase this voltage. You can see this supply voltage is increasing. You can see here. You can see here the supply voltage is now 130 volts. You can see the output voltage is 5.3 volts DC, and I am charging my battery as a load. You can see here the voltage is rock steady 5.3 volts and the input voltage is 130 volts DC. You can see if I reduce the input, you can see if I reduce the input, output is still 5.3. You can see this 5.3, it is constant. I am reducing the input. You can see here I am reducing the input. You can see I am increasing it further. You can see, but the output is constant. You can see. So this is how my SMPS works. This is the complete layout. Thanks a lot. Thanks for watching. I am going to attach all the design files in the description link. Thank you so much.